Okay, this is Thursday, and we finished our little mapping project up in Lost Gulch yesterday and got out of there in good shape. And today we are, listen if you can. So we are right off the runway at Ellsworth Air Force Base, and we are with the US Geological Survey today, and I'll introduce you to that crew later. So we are in a field right off the runway that has some groundwater contamination issues from fuel, and I don't know what all is here, but airbase related. And so this is an actual project that USGS is working on to identify contaminant sources here and then start remediation type things. So we're doing resistivity surveys today, and that's where it's a geophysical survey using electrical current into the ground to determine where, I think what they look for and what they actually find is like gravel layers and water table and things like that. So this field is full of wells out here. There's well heads everywhere. They've been collecting data out here for some time, and so we just came out here this morning to help them run a seismic line, or not a seismic line, but a resistivity line, and collect some data. It is wet. You can see the vehicles right up here. They just had to pull me out. We just stopped driving down this little trail here, and we just stopped. So the ground is soft and soggy, so we had to hook a chain up to the front of the van, and then the students pushed, and we got my van out. And so I just went ahead and drove down to here, and the other van behind me stopped, and now I see them pushing. They're trying to work it out. So we thought we were going to be doing work, or getting vehicles unstuck. So here's some equipment here. So here's the line that actually collects the data, and these spikes drive into the ground and then connect on these metal pods, so they're laid out in certain distances. And then this makes the connection to the ground, ties to the cord, and then electrical signal is pushed through the wire and then records the data from the subsurface. I'm sure it's way more technical than that, but that's the basic premise of how it works. Looks like they're having more trouble with this van than they had with mine. Dear Carter, happy birthday to you. Yeah. All right, so we are here with birthday, celebrating birthday. It's also the 50th anniversary of the Rapid City flood today.
Oh, that's right.
And so we are with United States Geological Survey. You've already met Bill Eldridge, Colton Medler. This is Todd Anderson and Kelly, who is going to be a new student at School of Mines come fall.
Cool.
And we are out here, as you've already seen, at the base of the runway at Ellsworth Air Force Base, and going to be assisting these professionals, probably mess everything up for them, conducting some resistivity tests today. So Bill and Colton probably are going to lead us through and tell us what we're going to be doing. So
yeah, go ahead.
So today we're going to be doing electrical resistivity surveys, and the purpose of those surveys is to delineate the bedrock surface, which we think is somewhat responsible for determining the groundwater flow directions out here. So, and you know, I guess we'll take you through every step of the process as we get there, but has anybody here done that kind of stuff before?
Somebody with some hours.
Single, yeah. So yeah, Grace helped us last summer do a lot of this, so she's intimately familiar with it. But so how it works is that we have way down there we drove past the super sting, which is actually controls all the current inputs.
Technically, I didn't drive past it.
No, you did not. Stetler did. He flew by it. But so it controls all the inputs and it measures all the outputs. So what we're doing is we're sending a current into current electrodes, and we're measuring the potential between that current electrode and then 8 potential electrodes. And it does that, you know, it alters which electrodes are current electrodes and which ones are potential electrodes, and it'll complete that along the length of the line that we lay out. So what we have is 4 cable sections, each with 14 electrodes, and we'll attach those electrodes to stainless steel stakes, and then right in the middle of our line, so cables 2 and 3 will be hooked up to a super sting, and that'll be what sends the current into the cables. But then, so the initial setup, what we're going to do is we're going to do 5-meter spacing between our electrodes, and since we have 56 electrodes, it'll be 275 meters will be the first part of our line. And what we'll do after that is called a roll along. So what we're going to do is we're going to pick up cables 1 and 2 and move them to the end. And then we'll move the super sting as well to be in the middle between 4 and 1. So it'll make more sense when we get it started, but I'll let one of these other guys talk about, you know, these contraptions over here.
Okay, so part of what we're doing, like Colton said, is we're basically trying to map the subsurface and changes in lithology underground. And in order for our cross-section to make sense, we need to know accurately what the land surface is, the elevation of the land surface. So we're going to use real-time kinematic surveying equipment. I know if you went to school of mines, you had a surveying class. I got some nods, a couple nods, yes. And what we're doing for this particular one is we set up a base station right here. This base station is going to sit here for several hours and collect information from GPS satellites that are cruising overhead of our noggin right now. And then as it's collecting that data, it's going to more and more precisely define the point that we put it at. We picked a random point in the field close to our survey line. You could set up the base station over a known benchmark point too. Tell it, okay, you are here, and then I just want you to collect and get super accurate. So the base station is going to figure out where it is. It also provides information to our rover. So this is the base, this is the rover. And the rover is what we're going to do to go along our line, along every one of those stakes, and we're going to measure the elevation and the position of every one of the stakes. At the end of all that, this base station that sat here for several hours collecting data is going to make a correction. We're going to send that file in to the National Geodetic Survey. They take the file, they compare it with known GPS locations and other satellite information around the area we're collecting, and they'll give us a correction. Then we take the correction and we apply it to our rover. That correction is usually maybe a half meter or a meter. But I know Colton said that he was going to send you the cross section for the section we take today. What I can do is send you an uncorrected elevation file, and then you could use that, or we could import that into his cross section profile for the resistivity, and you should be able to see the land surface on top. So we will have a team doing this, and Kelly will be supervising that team, and we'll probably have another team putting in those nodes, as Colton called them, which are steel stakes that get driven in the ground. And then we'll have a team unraveling cable, and I'm sure Colton will show how to set up the super sting and all that. Other thing to note is there's a lot of prep work going into this. We don't just show up and go, hey, let's put a line out here. This looks good. What do you think, 5-meter spacing? So we determine the spacing based on the depth we needed to look at. We're building a grid in this field. So we're doing east-west lines, and we're doing west-east lines, and we're doing north-south lines. And our idea is to get a whole bunch of points for this field so that we can hand all that information to Todd, and like Colton said, build a really accurate 3-dimensional surface at the top of the pure shale. So did you mention the lithology here already? So what we've got on top? And
Nope.
So
Go.
Well, you've written about it more than I have, so go ahead.
So the primary bedrock unit out here is the pure shale, which you might already be familiar with if you've mapped it already. It's just a black Cretaceous shale that's pretty gooey and sticky when it gets wet, which you might have got stuck in down there. And then overlying that are alluvial deposits from current streams and Box Elder Creek. That's just about maybe a half-mile south of us. Then up as you get higher, there's quaternary terrace deposits that are probably just remnants from, you know, old flows in the probably Box Elder Creek from however many years ago. Those usually consist of like gravels and sands and, you know, interbedded with clays and whatnot. So we're expecting the bedrock to be maybe between, you know, 10 and 30 feet below land surface here. So, but this survey will tell us, you know, what we should expect. And if there's any, you know, as you've seen, there's a lot of wells in this field too, so that'll actually help us interpret what the bedrock thickness is, or the overburden thickness is.
Can you tell us a little bit about why you guys are out here doing this in terms of, okay, why is it important to figure out where the bedrock is? What's the overarching goal here?
So we're trying to map where the bedrock surface deviates from the land surface. And in those areas, the bedrock surface might be controlling the direction of groundwater flow. Because there have been some studies out here, and groundwater has been flowing in directions where they didn't anticipate it to be flowing. And that's important for, you know, like remediation efforts and things like that. So we're just trying to gather more information about, you know, certain areas where they wanted us to look at. And this is one of those fields where the direction of groundwater flow is a little different than expected.
Well, and I guess too, to get to Kurt's point, the reason why they're interested in it right outside an Air Force base is because a lot of military installations have been around for a long time. This base was built in 1940, and it's been around for many years, a lot of different aircraft. A lot of military installations back in the 40s and 50s, the environmental laws were not the same as they were today, right? So if you had degreaser, oil, or extra jet fuel, what did you do with it back in the 40s and 50s? Yeah. Where did they dump it? Do you dump it on the base? Just off, yeah, through here. So there's a lot of contaminants in that, the deposits above the pier shale. And so the reason you want to know the direction of groundwater flow would be because what's in the groundwater? Contaminants, right? So it's super important if we do get to the time when you're doing some groundwater levels that you decontaminate that equipment when you get back. And by decontamination, I mean soap and water will be fine. So anything you dump into one of those wells, make sure you decontaminate it. So yeah, the idea is that if the direction of groundwater flow, like Colton said, at the surface of the pier shale is different than what it is at the land surface, and they can predict how those contaminants flow. And as you know, what else is around here that people that might be concerned about contaminant flow? Do you think these guys are on city water? They are now. Yeah, they are now, but they weren't at one time. So the government has to compensate these homeowners for contaminated wells. And part of that compensation is to know where the contaminants are, and then either pipe city water from Box Elder or provide them drinking water delivered in trucks. So knowing where the contaminants are and where they might be in the future, as engineers, that's one of the things we do, right? You learn equations and then you use those to predict the future is key so that the base can plan how to do compensation or how to remediate it, like Colton said. If you could clean up this field, that'd be even better. So, does that answer your question?
Yes, yeah, thank you.
Okay. All right. T, what do you
Yeah,
think?
I think maybe half of us down here, and then another half will walk down there with Todd or I and get started.
We have a stake that always goes into the tape. We made a shape file in GIS of all the lines that we were doing. We loaded that into the Trimble survey system, and then we laid out flags along that line. And then after we have the flags done, we lay out the tape. And then, like Colton said, you guys remember our spacing?
5 meters.
5 meters. Okay, so every 5 meters, which also when we did surveying the very first day, I remember they made us do this pace thing, which I thought was silly. We got all this technology. But guess what I roughly do for 5 meters? I go 1, 2, 3, 4, 5.
Yeah.
5 meters right here.
Yeah.
And here's a stake. Now, when you guys are pounding these in, what the electrodes? See those electrodes on Todd's cable? Those are going to attach to this little, an L-shaped little mechanism. So we want these L shapes either along the line. It could be either way, to the top or to the bottom. And then, boom. The other thing to do to help out the cable guys is just rotate the spring to be in line with the L shape.
You want them to pound them down till the spring is basically flat?
Yeah, till the spring is just above.
Don't kill yourself pounding it in, or if you're gonna rock and pull it up.
Yeah. And this is pretty gooey land.
The ground is going to get softer as we go that way too.
It will get
Push
softer.
it in.
All right. I'm not gonna ask for advice here. You two guys are gonna do stay foundation.
Oh man, I don't know.
Don't hit the tape.
Come on, two-person job.
Okay, cool.
there?
Yep, that's perfect. And then the L lined up. Yeah, and you can either do it by hand or this material is a little bit easier to pound stakes in. There are times when it's not so easy. And then what you can do is use the side of the hammer to kind of get it aligned along the tape. Okay, I think you guys pass. Knock yourselves out. Stop when you're out of stakes. If you got any questions, holler.
That's gonna go closest to me. So we start at 1 and we just go all the way to 14. Then we'll connect the next cable to this one. And I'll let you all do that one.
Because it was in the green the whole time.
So yeah, Kelly, show them a couple and then have them knock themselves out. She has a 6 pace.
Hopefully I don't get in a tangled mess while I'm demonstrating.
That'd be embarrassing.
Here's how to do it.
I've only been doing this for 3 years. So I'm just gonna kind of serpentine my way through these stakes while I unroll it. And then if
pretty gangly mess of cable.
one of you guys trailing me wants to connect these nodes, Grace, you want to show them how? Grace knows how.
First I do it like that and then I break it up so like it's not just holding it.
How much cable is between the nodes, Todd?
10 meters of cable.
It's 10 meters. Okay.
Yep,
So you can go anywhere from 1 to 10 meters spacing.
that's right.
And the further the spacing, the deeper the signal.
That's right.
We can usually get about 1,000 meters done a day. Wow. We also do this every day.
Oh. That helps. So this is your primary gig here? It is when we got the money for it.
Stripping on the weekends. That's what I figured. Get some better money coming in, you know. 80K starting male strippers in Tampa. Not a bad gig. That's starting.
All right, you guys are acting like old hands.
Yeah.
So you guys can trade off at the super sting if you want to.
Okay, so what are you doing, Kyle?
I am increasing the conductivity around the stakes.
All right. That'll work.
The contact resistance
Listen up,
between
guys.
each stake and the ground. And if they're too high, that's not good because you can't get enough current into the ground to measure. So what it does, it goes from 1 to 2, 2 to 3, 3 to 4. It starts from this end and goes all the way down there to the end. And it tests that resistance that the ground's giving between the stake and the ground. Then after this is completed is when we can actually start the measurement. And the measurement takes about an hour and a half or so. So in that meantime, we might go visit some wells and get some water levels and stuff like that. And then after that 80 or 90 minutes is completed, we'll do a roll. So we'll pick up cables 1 and 2 and we'll move them to the end. And then we'll bring the super sting and put it at the end of cable 4 down there.
So how many stakes are in?
56.
56.
Yeah, each there's 4 cable sections, each with 14 electrodes. So there's
Okay.
56 total electrodes. No issues.
Good job, guys.
All the contact resistances were low. All right, now we wait.
So it's on. It's on and running?
Yep. Yeah, so nobody touch the stainless steel stakes, or there's like I said, you could die from it. So just don't do it.
Do it. Watch your step.
If you die, you don't get around.
Mess up the system.
We're gonna have to chain
But
that.
everyone else does, right?
Chain mass into the van.
Whoa.
Wow.
Rocking in the Hames section.
Oh my gosh, we shot in this thing.
Oh, remember those lines that we did like right by the runway?
I don't even know that.
Uh-oh. Did you drop something in the wall?
Stellar. Yeah, I thought so.
Are there tubes in there?
Uh-oh, not anymore.
Oh no. Colton, did you have our fish hook?
Might be in the truck. What did we drop in there?
I think it was just one of those tubes. Yeah.
Uh-oh.
Okay, we got something like 300 meters of line done. Oh, here comes a B1 in. Let's see where he's going. Well, he's not landing. He's going at kind of some really weird obtuse angle to the runway. But he's in a tight turn. I bet he's going to come back in and land.
Did we dip the water out of this? Or do you
We're going to use it tomorrow.
Okay.
So it's good.
Well, and he's down, and we're out of here. Thanks for watching. See ya.